Okay, so we have 6 trig functions, and each trig function will have its own derivative or slope formula. The two most common ones, or the two most important ones, are these two here. I mean, we're responsible for all 6, but the derivative for sine is simply cosine. So that means the cosine is going to describe the slope behavior of the sine graph. Okay. Also, the derivative of cosine is negative sine. So negative sine will do the job of any value I plug into x for negative sine of x. In return, it'll give me a number, and that number will describe how the slope is behaving on the cosine graph. Okay, so, but we see that they really just involve each other in terms of describing the slope of the function. Okay. Now, here are the other ones. Okay, tangent's derivative is secant squared. Cotangent's derivative is negative cosecant squared. Secant's derivative is secant tangent, and cosecant's derivative is negative cosecant cotangent. Okay, so these are 6 we have to make sure we have to be able to memorize. But I have a way of working through and showing patterns to help us memorize these 6. But example 1 just says, show that the following are true using the above rules of product and quotient. So we're going to practice product and quotient rule from so we're just going to derive these rules simply by relying on these ones that we see above. Okay, so let's say we start off with tangent of x. Okay, and tangent can be represented as sine and cosine. What's another way to write tangent? Tangent equals to what? Okay. It's sine over what? Over cosine, right? We know that is another representation of tangent. So we know tangent is sine over cosine, and if I asked you to find the derivative of something in this form, you would go through what? Quotient rule, yeah. So imagine we're just doing quotient rule here. So the hope is that we find the derivative, and this cleans up to be secant squared. Okay, so we want to show that that is going to be true. So this is our function here. Here's my f, and here's my g. We'll go through quotient rule. Okay, so based off of these two, this is the only thing that we need here. What's sine's derivative? Cosine. Times the original g function, which is cosine. Minus the original f function, which is sine. G prime, what's cosine's derivative? Negative sine. All over cosine of x squared. Okay. All right, let's clean up the numerator here. Cosine times cosine gives us cosine squared. Negative sine times negative sine gives us positive, yeah. All over cosine x squared. Okay, there's an identity here. Do you guys remember this? What's cosine squared plus sine squared equal to? Equal to 1. So I have 1 over cosine of x squared. And 1 over cosine of x squared is the same as what? Secant squared. There it is. So we proved it. Okay. The derivative for tangent is secant squared. Let's do one more. Let's do part C here. Secant, we know secant's derivative is secant tangent, so we're going to try to prove this. But all we have right now is to rely on just sine and cosine. How can I represent secant in terms of either sine or cosine? 1 over cosine. Now we can go through a quotient rule here, but what's another option that we can do? Yeah, we can bring it up to the top. And we can go through what rule here? Chain rule, yeah. Outside times inside derivatives. This gives us a chance to kind of practice chain rule here. So chain rule says outside derivative will take care of the parentheses to -1, and then inside derivative will take care of cosine of x. Excuse me. Hey, what's parentheses to -1's derivative? Negative parentheses raised to the -2. Okay. What goes inside the parentheses? Just cosine x. Okay. Times, okay, what's cosine's derivative? Negative sine. Okay, so we're going to just try to clean this up in a way that will match that secant tangent. We'll see how far we can get. So the two negatives, first of all, they cancel out. Cosine of x to the -2 is the same thing as 1 over cosine x squared times sine of x. So maybe we can rearrange this. Let me put all this in their one fraction to see maybe we can see something develop. So I split that cosine squared x into cosine x, cosine x. Okay, we're trying to target secant tangent. Do you see a path for us to get from here to here? What do you see? A little cleaner than that. Maybe we can just rearrange it and then do you see something that's equal to tangent in here? So what if I do this? What if I do, I'm just rearranging these fractions around. What if I said sine of x over cosine of x times 1 over cosine of x, right? It's the same thing. I just separate it in a way that may be a little bit easier to see. So sine over cosine is the same thing as tangent. 1 over cosine is the same thing as secant. So there we have it. Tangent, secant, which is the same thing as secant tangent. Okay, let me organize these 6 rules in a way that will hopefully help you begin to memorize them. So example 2 is not going to take a lot of space. We'll come back to example 2. So example 2 really is just going to need just a quarter of that space. I'm going to use this space here to kind of show you how I want you to build your knowledge for your derivative rules. And I want you to put it in this form here. We're going to do 1, 2. Let me move that 2 over a little bit here. I want to make sure I have enough room on this side. Okay, so I want us to put the rules in this form. I think this is the method that I find easiest to see patterns, and the more we can see the patterns, the easier it is to connect them together. Now, I'm also building the chain rule portion into it. You know how with all of our rules, I would say natural log of u is u prime over u. E to the u is e to the u times u prime. That u prime is really a built-in chain rule to help us remember to look for that u prime every time. Sorry, didn't you? Okay, so we're going to have the sine, tangent, and secant lined up in the first column. The second column are all the functions that start with C in alphabetical order. So you got COS for cosine, COT for cotangent, CSC for cosecant. So there's something nice about all the C functions that we're going to see in a bit. So the derivative of sine is cosine of u times u prime, as a reminder that we always want to look for that chain rule portion, especially if there's something other than x inside your u. Cosine's derivative is negative sine of u times u prime. Okay. Tangent's derivative is secant squared u times u prime. Cotangent's derivative is negative cosecant squared u times u prime. Secant's derivative is secant u tangent u times u prime. And cosecant's derivative is negative cosecant u cotangent u times u prime. Okay, so I want to point out a few things, and hopefully at the end of class we can kind of begin practicing memorizing these rules, and then we'll do it every day leading up to the quiz. Now, what do you notice about all the C functions? What's nice about these C functions all lined up together? Yeah, that's a nice thing there. All your C functions will produce negative derivatives, so that helps us remember, okay, which derivative is negative, which ones are not. If your function starts with C, it'll produce a derivative that starts off with a negative. The ones that are across from each other kind of have a similar pattern. We know that sine is cosine, cosine is negative sine. So these, hopefully we can memorize. These are the most important ones. Okay, so we have to make sure we memorize this. These will most likely show up on the AP exam. These other four, there's a decent chance that they may show up, but not guaranteed every exam is going to have all of them show up. Tangent and cotangent, they both have a similar form. They both involve the square of a trig function. So that's nice to have that pattern for us to see. Secant and cosecant, they both have a similar pattern. They both involve two different trig functions. Secant is secant tangent. Cosecant is negative cosecant cotangent. And then one more thing I want us to see is that your tangent and your secant derivatives will just involve each other. So tangent is just secant squared. Secant is just secant tangent. So tangent and secant, they just both involve each other. And then cotangent and cosecant will just copy what tangent and secant is doing. Cotangent is just involving cosecant. Cosecant is just involving cosecant cotangent. So just seeing all these patterns, hopefully that's my hope is that on the quiz, you're able to just put this at the top of your page and you have 6 rules in front of you. And also on the AP exam non-calculator portion, that you can just have write these 6 rules at the top and then as reference. And then if you come across a derivative rule, you can always go back and refer to it. And also, this is leading up to next semester, I know, but this looks like 6 rules in front of you, but this is actually 12 rules. Okay, the reason why there's 12 rules is because next semester we're going to learn about antiderivative rules. Antiderivative rules are simply just going backwards from the derivative rules. So the derivative of sine is cosine, but the antiderivative of cosine is going to be sine. So I think it's just so helpful to have these 6 rules memorized, because you're also setting up yourself for next semester when we can go backwards and rely on this to get to our integral antiderivative rules. Okay, so let's try example 5. Now example 2, now that we have these in front of us. So my function is sine of 5x. I want to find y prime. So I'm just going to follow whatever the rule tells me. So sine of 5x, my 5x is the u value. So sine of 5x derivative is just simply what? Cosine of 5x times 5. That's it. Now understand the 5 is outside the 5x. We can't make that cosine of 25x. The 5x is inside the cosine function. These are stuck together. These are not independent of each other. This is a package deal here. So best we can do is pull that 5 out in front. The 5 is coefficient. It cannot merge with the 5x inside the cosine. Okay, page 12, page 10. Now, the thing with trig functions is that whenever we see a radical or something that is written where we can use parentheses, we want to do that. Okay, so it's just like how we saw, if we see a radical, we always want to write it out as a rational exponent to help us see the problem a little bit more clearly for us. So let's rewrite this problem here. I can rewrite this as cosine raised to the what? Yeah. So guess what we have to apply here? A chain rule, yeah. So we have an outside and inside portion. Okay, we'll do outside first. Parentheses 1/2 becomes 1/2 parentheses to the what? Negative 1/2. Inside is no changes with my inside function just yet. Times, okay, so now we're ready for cosine of x squared. Cosine of u becomes what? Negative sine of u times what's u prime? 2x, yeah. There's my full outside derivative. Here's my full inside derivative. Okay, we'll do a little bit of cleanup here, try to get that negative exponent resolved, but we're just going to put everything under one fraction. The 2 goes below, the cosine squared goes below, the 2x and negative sine squared x squared goes above. You can also bring the square root back into the answer if you want, but just no negative exponent. Okay. Can you try example 4? Example 4 should feel like example 3. Rewrite it using rational exponents. Identify your outside, inside, and go through your derivative. Okay. Got a key on the next page. You guys can also check your answer there. Okay, very much the same pattern as example 3. We identify the outside portion, we identify the inside portion, we take turns with their derivatives. Chain rule, 1/3 parentheses to the negative 2/3. That takes care of the outside. The inside, tangent of u becomes secant squared of u times u prime. Okay, so now we're just trying to clean things up here. I think on my key, I took out a GCF of 3 and reduced this to just 8x cubed plus 1, but you don't have to. Example 5, we're just going to find y prime. It says find y double prime, but we're just going to find y prime. Okay, so this is one of the biggest trouble spots for students with trig functions, and that is with this shorthand form. What is that squared impacting? It's impacting the entire function. Okay. This is the way that, you know, if any trig function is squared or cubed or raised to the 4th power, it'll always be represented in this form. But it is not the most helpful form for us in terms of derivative wise. So whenever you see this form, you always want to rewrite. Using parentheses. The reason why this is written the way it is because it can represent, it's basically you save some parentheses rather than writing it out using parentheses. This is always going to be the way that a problem is presented in this form. But the reason that we want to rewrite it is because if we don't rewrite it, we're going to have trouble seeing the chain rule portion of it, and it's easier to make a mistake. Okay, so we're always going to rewrite using parentheses. Okay, that's the biggest trouble spot. Sometimes students jump into the derivative in this form, and there's always something that's missing. Okay, it's a lot easier to see your full extent of chain rule if you rewrite it. So I'll use brackets or parentheses here. I'm going to write it as secant pi x. Okay. It's obviously more cumbersome in this form, but for us, it is more helpful, especially if we're trying to find the derivative. And so now it becomes a lot easier having that bracket there to help remind us that there's chain rule here. What's the outside portion? bracket or parentheses squared, and the inside portion is secant pi x. Okay, so try that. See if you can finish off this derivative now that you have everything laid out. Outside derivative is simply power rule. Inside derivative, secant derivative is secant u tangent u times u prime. Typically, I like to pull my coefficients out in front. And then I can also merge these together. These are the same. But you don't have to. I just want to show you what a cleaned up version could look like if you were doing a multiple choice question on the AP exam and you're trying to find your answer choice. It'll most likely be in this form. Okay, example 6. Can you recognize the process we have to involve here? Implicit, yeah. We see more than one y. Y is not like the previous problem where y is by itself. It's mixed into the equation here, so therefore do implicit. Let's remind ourselves that sine is not independent of x plus y. We cannot distribute this through. This is stuck as one thing. So we got to jump directly into our sine rule. Sine's derivative is cosine of u times u prime. So cosine of x plus y times what's inside parentheses derivative. X becomes what? 1. Y becomes ui dx. We continue with our derivative process. 3x becomes 3. 2y becomes 2 ui dx. Okay, we want to solve for dy dx. Now we can distribute through, okay, because now cosine of x plus y is clearly outside of 1 plus dy dx. We want to kind of free that dy dx away from the set of parentheses. So we'll distribute that through, and then we can start moving things around and try to get dy dx by itself. I'm going to put these two terms on the same side and have the other terms on the other side. Okay. GCF can come out. Oh, sorry, dy dx can be factored out. Okay, simply divide the parentheses over. Can I go any further and take these cosines out? No. Okay. Attached to this addition and subtraction, we cannot cancel out. It was 3 times cosine divided by 2 times cosine, then yes. But as soon as you introduce addition and subtraction, unless the GCF can come out, we can't move any further. Okay, page 13. Okay, some of these problems, your 13 is going to be your homework. I'm going to just make sure that we can start each of these problems, and then you guys can finish them off. Look at number 1 here. What would the first thing that you want to do here? Let's rewrite it, right? That 3 is telling us there's chain rule going on, but it's hard to know what the full clarity of chain rule is unless you can see that bracket cubed showing up. So your first step is rewrite it and understand that we want to see the full extent of chain rule here. Okay, now it becomes a lot clearer, right? Chain rule, there's an outside portion you got to worry about, and there's an inside portion you got to worry about. So now you know what to do, right? Outside's derivative times inside's derivative. Okay. Okay, so we'll leave that for you guys to finish. The key is on the next page, so you guys can always check your answer later. Number 3 here, it says evaluate y prime of 0. So we're going to ask to find the slope. Before we can find the slope, we first have to find the derivative, right? And to find the derivative, look at this form here. We got to go through what? Quotient rule, right? So after you go through quotient rule, f prime g minus f g prime, then replace every x with 0, and then use your unit circle values to get it down to a numeric answer. Okay, number 3, sine x over 3 cosine y equals 2x. What can we do here? What's involved here? Implicit, yeah, you see y kind of stuck inside the problem here. What else? We want to find the derivative. Quotient rule. Another option that you can do is you can cross multiply and go through product rule. That's another option that you can do. But on my key, I went through quotient rule, so maybe that's a little. So what I did was I went through quotient rule, and then I cross multiply, and then I solve for dy dx. How many dy dx will pop up within this derivative? Just one, yeah, only one dy dx. We can skip number 4. 4 is a little, this is not clean here, so we'll skip number 4. For number 5, it says this is particle motion here. If velocity is sine of 2t times tangent of t, find acceleration. So acceleration is what compared to velocity? It's just the derivative. And if I want to find the derivative from velocity to acceleration, what's involved here? What do you see here? Product rule. Okay. So f prime g f prime g plus f g prime. So after you find acceleration, then you can replace every t with pi and use unit circle values to get it down to a numeric answer. Okay. But what I do want to do with you is number 6. Okay. So number 6, let's go do that together. Find the equation of tangent line at x equals power 4 for 2 tangent cubed x. So we're going to find the derivative, find the order pair, find the slope, point slope form. But if I want to find the derivative, what should we do first? Yeah, let's get that. That 3 is not going to be, if you try to find the derivative in this form, you're most likely to make a mistake. Rewrite it using a set of brackets. So y is equal to. Now, is the bracket going to include the 2 or not include the 2? Not included. That cube is only influencing the tangent. It's not influencing the 2. So the 2 is outside of it. So 2 bracket tangent of x cubed. Okay. So we definitely want to go through chain rule here. Outside portion is the 2 bracket cubed. The inside portion is the tangent x. Now we can do our derivative rule, right? Chain rule. So 2 bracket cube. What's 2 bracket cubes derivative? Six bracket squared. Yeah, we just go through power rule, pretend the bracket is its own variable. The tangent goes inside. Times, okay, what's tangent x's derivative? Secant squared x. Okay, so to find a tangent line equation, we have to find order pair and slope. So I'm going to insert power 4 into tangent x to get the order pair, and I'll plug power 4 into the derivative to get the slope. Once I have my order pair and my slope, I can do my tangent line equation. Okay, let me find my order pair first, since this doesn't give me my y value there. So 2. Okay, so let's think back on unit circle values. What's tangent of power 4? 1. 1 cubed is 1. 1 times 2 is 2. So there's my order pair. Okay. Now let's plug in power 4 in for our derivative to get our slope. I'm going to put that secant out instead of parentheses too, as I'm evaluating, makes it easier. Okay, so tangent of power 4, that's nice. That's just going to be equal to 1. 6 times 1 squared. Now, secant of power 4. I like to think in terms of cosine first, and I can just flip it. What's cosine of power 4? And I could just flip that, right, to get my secant. I think it's easier to think in terms of sine, cosine, tangent than it is for me to think in terms of cosecant, secant, and cotangent. So secants, we know cosine is 2 over 2. If I flip that, I get 2 over root 2. And I square that. This just cleans up to be root 2. Root 2 squared is 2. 2 times 6 is 12. There's my slope. So this is basically the basically what your quiz will look like. Okay, in terms of there's chain rule, there's product rule, there's quotient rule, implicit, a little bit of particle motion, but you really just find the derivative and tangent line equation, right? So we have we have Thursday, Friday, and the Monday after break to review, and you kind of know this already. We just have to make sure that we're good with our unit circle values, that we're good with our new derivative rules. Okay. All right, so your homework is page 13. You can skip number 4. So we started each problem, so you know how to begin, and you also have the key attached. Okay. All right, go get your phones. I'll check this on Thursday. I'll send out a reminder tomorrow night. Oops, that's nice. Oh, I'll be at student service. Oh, so tomorrow is most students are gonna be out, so it'll just be we're not doing anything about it. Okay. Yeah, you can come by.
I was just wondering, like, I think the number is very short, so I can calculate for something. So I wonder if I to find more practice of some of the
And give you a blank copy of the test as well.
Oh,
Yeah.
correct. Like the same
Yeah.
But like they're like the retake will be the same one, just different numbers.
Right.
Like same format of all 8 pages. Yeah, I'll take up one and then I'll get like that after. So
Okay, sounds good.
Thank you. Yeah, that's like nothing.